In his very famous book Principia Mathematica, Newton proposed three laws of motion, as if any moving body or any body at rest is going to follow these laws. Right now, our focus is on law number 1. But before that, let's dig into the story from where it all began. From where people started thinking about the rest and motion of the bodies. Because it didn't start with Newton, it started long way back. One of the very famous philosophers of his time, Aristotle, has to say a couple of things about motion of the objects. First point, all objects have a natural place in the universe. For example, the natural place of rocks is on Earth, or the natural place of smoke is in the sky, or the natural place of stars is in heaven. This is what Aristotle used to think. Okay. The second point is the natural state of any body is rest. According to Aristotle, any object which is moving will eventually come to rest. And it is very easy to believe, right? If you are hitting a football, eventually it is going to come to rest, no matter how hard you hit it. Correct? But there was one person who was against it. There was one physicist who has some other point of view, some other thought process. Galileo Galilei. According to him, a force is necessary to change the velocity of a body, but no force is necessary to maintain its velocity. Or in other words, in the absence of a force, a moving object will continue moving. And we have a proof for that, we have an evidence for that. This is Voyager 1, a probe launched by NASA into the space on 5th of September 1977. And actually on 20th of March 2020, it was 22.2 billion kilometers from the Earth. The farthest man-made object from the Earth. And it is still moving forward into the deep space. Now the question is, what keeps it moving? There is no fuel inside it which can keep moving it for so long. Then how it is moving? It is actually because of a property which we call inertia. Any body or any object will resist a change in its velocity, and that property is called inertia. So Newton gave a law in reference to this property. According to his first law, every object will remain at rest or in uniform motion in a straight line unless compelled to change its state by the action of a net external force. Which means that any object which is at rest will remain at rest, or any other object which is in motion in a particular direction will continue its motion with the same velocity in that particular direction unless there is a net external force acting on that body. Now the question is, what do we mean by a net external force? What is this? For example, let's say we have a block or a box and multiple forces are acting on it in different directions. Let's say they are F1, F2, F3 and F4. The net force on this box is actually equal to the vector sum of all the forces acting on this object. So we can say in equation form as F net is equal to vector F1 plus F2 plus F3 plus F4. Now according to Newton's law, if this vector sum of forces acting on a particular object is 0, then we can say that a body at rest will remain at rest, a body in motion will continue the motion with same speed, and there will be no change in direction of motion of this body. And these 3 points are valid if and only if the vector sum of all the forces acting on that object is 0. Let's take an example. Here we have a book kept on a table, and we can say that it is at rest, it's not moving, right? So let's apply the Newton's first law to it. Very obvious, there is a gravitational force acting on it, right? Which is equal to mg. You know that. Now, if it is at rest, the net force should be 0, correct? Which eventually means that there should be another force acting on it opposite and equal to the gravitational force to keep it at rest, right? Now this force is applied by the surface of the table, which we call normal reaction, and as a result the net force on the book is 0. mg is equal to n, and because of which the net force on this book is 0, and that is why this book is eventually at rest, correct? Now let's analyze the clip with which we started. The experiment has actually been conducted at International Space Station, where we can say that there is almost no net external force acting on the objects kept inside this station. And since there is no net external force acting on it, let's see how they behave. Let's see if Newton's first law is applicable to the objects kept inside it. Now if this video looks interesting to you, do like, share and subscribe, and yes, hit the bell icon for the notifications. Now if you have any doubt or queries, you can drop a mail at slidescreen@gmail.com.